And we continue working on linear equation in two variables. Linear equation in two variables is a straight line in the rectangular coordinate system, right? Okay, yesterday we were on example 2. We completed the table here. For the given values of x, we found the corresponding value y. For the given value y, we found the corresponding value x. So the result means the following 4 ordered number pairs. The first pair, 0, -4. Second pair, 10, 1. Third pair, 8, 0. Fourth pair, 4, -2. They are solutions of the given equation, right? Yeah. Graphically, those are 4 points. Those ordered number pairs are points, right? Those points are on this straight line. Yeah, we know ordered number pair is a point. Linear equation in two variables is a straight line. So those points are on the line. Let me give you the rectangular coordinate system and let's graph or plot the 4 points in the rectangular coordinate system. And this is the x-axis, this is the y-axis, this is the orange. 0, -4. Where is 0, -4? On x-axis or y-axis? Horizontal scale or vertical scale? Yeah, 0, -4. 0, -4. If the x value is 0, means it's not to the left, it's not to the right. Yeah, it's on the y-axis, okay? It's on the vertical scale. Y is -4, so 4 units below, so orange. 1, 2, 3, 4. This point corresponds to 0, -4. So once again, second point, 10, 1. Which quadrant? X is 10, Y is 1, both positive. Quadrant 1, exactly. It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 10 units to the right, 1 unit above in quadrant 1 right here, right? Third point, 8, 0. 8, 0. This point has a y value of 0. So which quadrant or scales? 8, 0. X-axis, exactly. Is 8 units to the right. 8 units to the right of the origin on the x-axis. The last point, 4, -2. X coordinate is 4, positive. Y coordinate is -2, negative. Which quadrant? 1, 2, 3, or 4? 4, -2. Quadrant 4. Yeah. X coordinate is positive. Y coordinate is negative. So it's in quadrant 4. It is 4 units to the right. 1, 2, 3, 4. 2 units below. So it's 1, 2, 3, 4. It's right here. Quadrant 4, right? Yeah. So let's add something here before we continue. In quadrant 1, both x and y are positive. All the points in quadrant 1, both x coordinate and y coordinate are positive, right? In quadrant 2, x is negative, y is positive. In quadrant 3, both x and y are negative. In quadrant 4, x is positive, y is negative. And the last point, 4, -2, is in quadrant 4. Let's connect the 4 points. Let's connect the 4 points. They obviously collinear. And this straight line corresponds to the given equation, given linear equation in two variables. Okay? All right. So among the 4 points, 2 of them are very special. Yeah, 2 of them are very special. This point and this point, they are pretty special. How special? This point which is a comma 0, this point a comma 0, is the intersection of the straight line and x-axis. We have a name for this point. This point is called the x-intercept of the straight line. Okay? Yeah, let me write it down. 8 comma 0, this point is the x-intercept of straight line. The straight line is x minus 2y equals 8. All right? Yeah. Let me repeat the definition of an x-intercept of a straight line. X-intercept of a straight line is a point where the straight line cross x-axis. X-intercept, so x-axis. Am I clear? It is a point, so it has 2 coordinates. In this case, it's a comma 0. That point is the intersection of the straight line and the x-axis. So that point is the x-intercept. Similarly, we define y-intercept as the intersection of the straight line and the y-axis. In this case, the second black point, which is 0, 94, 0, 94. And that is the y-intercept of the straight line. The straight line is x minus 2y equals 8, right? Yeah, y-intercept is the point where the straight line cross y-axis. Let's fill this word intercept. Sept means cut, right? Sept means cut, right? Yeah, x-intercept is where the straight line cut the x-axis. X-intercept is where the straight line cut the x-axis. Y-intercept is where the straight line cut the y-axis. Am I clear about the definition of x-intercept and y-intercept? Yes or no? Okay. So let's look at the examples. We're going to see how do we find x-intercept and y-intercept for a given straight line. Let's see, let me find my example. Here, yeah. Finding intercepts. Let's look at the definition. When graphing the equation of a line, find the intercepts as follows. Let y be 0 to find the x-intercept. Let x be 0 to find the y-intercept. X-intercept is the intersection of the line and the x-axis. Y-intercept is the intersection of the line and the y-axis. So we're going to work on example 2. We are going to find the x-intercept and the y-intercept for the following given straight lines. Let's start from the first one. Number 1. Number 1, the equation is 3x plus 4y equals 9. How do we find the x-intercept and the y-intercept? What do you want to find, the x-intercept or y-intercept first? It doesn't matter. Let's find the x-intercept. To find x-intercept, we make y be 0. Yeah, you want to write down the sentence. Yeah, to find the x-intercept, we make y be 0. To find x-intercept, we make y be 0. That's how you get started to look for intercepts. All right, let's see in the equation, let's make y be 0. We copy everything in the equation except of y. We copy 3x plus 4, and when we see y, instead of copying y, we write 0 there. Because we make y be 0, right? In other words, we plug in y equals 0. Copy equal, copy 9. Yeah, so we copy everything in the equation except y. At the place of y, we put a 0 there. What is 4 times 0? 0, yeah. So this term disappears, is 0. So we have 3x equals 9. How do we solve this equation for x? Divided by 3. Very good. Divided by 3, we have x equals 3, right? Yeah. So when we find the x-intercept, we make y be 0. Solve for x. Once we have x, the x equals 3 corresponds to y equals 0. So this ordered number pair 3, 0 is a solution of the equation. 3, 0 is the x-intercept. Okay? Yeah, make sure you know x-intercept of a straight line must have y equals 0 because it must be on the x-axis, right? Do you see that? Let's see how do we find the y-intercept. To find y-intercept, we make x be 0. Yeah, you want to write that down as well. We make x be 0. And solve for y. Let's see, how do we make x be 0, solve for y? The equation is 3x plus 4y equals 9. We're going to copy everything in the equation except x. Yeah, in the place of x, we put a 0 there. So we plug in x equals 0 in the equation. What's 3 times 0? 0, right? So we have a 4y on the left. How do we solve for y? One more step. Coefficient of y is 4. How do we get rid of it? Divided by 4. Divide both sides by 4. So we have a y isolated on the left. On the right, we have a 9 over 4. Yeah, we can keep the fraction. So 9 over 4 corresponds to x equals 0. 0, 9 over 4 is the y-intercept of the straight line, okay? Graphing the straight line, graphing a given linear equation in 2 variables. In other words, graphing the line is very important in this chapter. One way to graph a linear equation in 2 variables is to find the x-intercept and y-intercept. Yeah, for example, for this one, we know x-intercept and the y-intercept. We got the x-intercept and the y-intercept. By common sense, we know 2 different points determine a straight line, right? Those are the 2 different points on the straight line. Let me graph the rectangular coordinate system. This is x-axis. This is a y-axis. This is 0, origin. Where is the 3, 0? 3, 0. That's x-intercept. It must be on the x-axis, right? X-intercept must be on x-axis. So 3 units to the right of the origin, that's the x-intercept. Where is 0, 9 over 4? 9 over 4 is a fraction. Can you convert the fraction into its equivalent decimal? Can you divide 9 by 4? What do you have? Divide 9 by 4. 2.25? Yeah? Hello? Can you use your calculator to divide 9 by 4 and tell me what you have? 2.25, right? Okay. Y-intercept must be on y-axis. 0, 9 over 4. So it's above the origin. This is 1, this is 2. So 2.25 is a little bit above. Yeah. X-intercept, y-intercept. 2 different points on the line. If we connect them, we have the straight line. So one way to graph a linear equation in 2 variables is to find the x-intercept and the y-intercept. And when do we do that? When the equation, we learned linear equation in 2 variables yesterday, right? When the equation is in the standard form. Do you guys remember? This form is the standard form. When you are given a linear equation in 2 variables in standard form, an easy way, most of the time, it always works. The easy way to graph it is to find the x-intercept and the y-intercept. I can show you why is that, why it's so convenient. To find the x-intercept, we make y be 0, right? We make y be 0, so this part disappear. Do you see what I'm saying? And you make y be 0, this part disappear. So you have 3x equals 9. Divide both sides by 3, you have x equals 3. Very convenient. When we find the y-intercept, you are given the standard form of the equation. You make x be 0, so this part disappear, right? Then you have a 4y equals 9 divided by 4, you have y equals 225. So when the equation is given in the standard form, one easy way to graph it is to find the x-intercept and y-intercept. Plot x-intercept and y-intercept on a rectangular coordinate system and connect them to have the graph. And most of the time, it's very convenient if the equation is in the standard form. And that's the first problem. We practice the finding x-intercept, y-intercept, and graphing the line. Second problem, can you do that for the second one? Let me see. Second one is x minus y equals 0. Second one is x minus y equals 0. Can you find the x-intercept and the y-intercept? Use the method that I just did. Yeah, this one might be special, you know. Yeah, find the x-intercept and the y-intercept. Let me know what you have. Want to find the x-intercept, you make y be 0. And let me know what you have for x. When you make y be 0. And look at this, how convenient. You make y be 0. You make y be 0. What is x? You make y be 0. What is x? Huh? You make y be 0. X equals 0, right? Yeah. So if you make x be 0, what is y? 0 as well. Yeah, okay. So what do you have? Yeah, this one is pretty special. Turns out when you make y be 0 and make y be 0, you have x equals 0. When you make x equals 0, you have y equals 0. So the x-intercept and the y-intercept, both of them are 0, 0. Is both the x-intercept and the y-intercept. And this straight line passes through the origin. Yeah, this straight line passes through the origin. So both x-intercept and the y-intercept is the origin 0, 0. And this one's pretty special. Now, how do we graph the line when the x-intercept and the y-intercept are both the origin? We can try this. What if we let y be 1? What if we let y be 1? What is x? Let's see what happens. If we let y be 1, we have x minus 1 equals 0. We plus 1 to both sides. Do we have x equals 1? Do we have x equals 1? Oh, okay, very good. So 1, 1 is on the line, right? Is on the line. Is a solution of the equation. So this point 1, 1 is on the line. When we graph the straight line, we have 0, 0. That's the x-intercept, also y-intercept. We have a 1, 1. Yeah, that's the second point we got earlier. 2 different points are enough for us to graph the line. And this line actually is very special. This line is very special. This straight line is the bisector of quadrant 1 and quadrant 3. Bisector. And then this is a 45 degree, and this is 45 degree. And this straight line is pretty special. It is the bisector of quadrant 1 and quadrant 3. All right. Yeah. Sometimes this happens. when the straight line passes through the origin, both x-intercept and the y-intercept are the origin. You try number 3. Number 3 is x plus 2y equals -8. X plus 2y equals -8. All right, I'll give you a couple of minutes. I'm going to walk around and you find the x-intercept and the y-intercept for this equation, okay? Yeah, you need to find the x-intercept and the y-intercept for that equation. That equation is a linear equation in 2 variables. Very convenient. I want to show you what I'm talking about. What did I say earlier? You make y be 0, right? You make y be 0. See how convenient. You get x. You make x be 0. You can get a y very quickly. Take your time. Find the x-intercept and the y-intercept for this equation. There's a one common mistake. Even some textbook, not very accurate. What I'm trying to say is both x-intercept and y-intercept are points. Points have 2 coordinates. It's an ordered number pair, right? So one common mistake is when you look for x-intercept, you make y be 0. You make y be 0, right? This part disappears. So you have x equals -8, right? Yeah. Common mistake is to conclude -8 is the x-intercept, but that is not accurate. X-intercept is not a number; is an ordered number pair. Okay, so x-intercept is -8, 0. Is an ordered number pair. X-intercept is a point. Is an ordered number pair. So, did you see what I'm talking about here? Yeah. So sometimes they say, okay, x-intercept is -8. That's not accurate, at least. Okay. It's not a value or one number. Is an ordered number pair. For y-intercept, we make x be 0. We make x be 0. You should have the value for y, right? You make x be 0. Twice of y is -8. What's the value of y? Twice of y is -8. What is y? Divide both sides by 2. Yeah, what is y? -4. Yeah. Very convenient, right? Okay. So once we have the x-intercept and the y-intercept, let's graph them. Let's plot them in the same xy plane or x coordinate, rectangular coordinate system. -8, 0. -8, 0. Where is it? It's here, right? Yeah. 0, -4. Where is it? Here, right? Yeah. So we connect them. We have the straight line. That straight line corresponds to the given equation: x plus 2y equals -8. And make sure you have the same answer. Do you guys have the same answer? X-intercept, y-intercept. All right. Number 4. Number 4. The equation is x equals 2. X equals 2. All right. Is this equation a linear equation in 2 variables? Were you here yesterday? If you paid attention yesterday, Is x equals to a linear equation in two variables? Linear equation in two variables. Yes or no? It is, right? It is a linear equation in two variables. You do not see variable y because coefficient of y is 0. Remember that? Yeah. What kind of straight line this is? It is a linear equation in two variables, so it is a straight line. What kind of straight line this is? Huh? What kind of straight line? X equals 2. Vertical? Horizontal? Vertical or horizontal? Vertical. Okay, so it's not very difficult to remember. It's easy to remember. This is the XOY plane. This is the rectangular coordinate system. X equals 2. X equals 2, so you look at the x-axis. You look at the x-axis. X equals 2, so you go here, right? 2 units to the right of the origin. And you're going to draw a vertical line. And that is x equals 2. All right? Yeah. A linear equation in two variables without a y corresponds to a vertical straight line. Look at this vertical straight line and tell me what's the x-intercept and the y-intercept. X-intercept and y-intercept. Let me repeat the definition for x-intercept and y-intercept. X-intercept is the intersection of the straight line and x-axis. Is a point, so it has 2 coordinates. Y-intercept is the intersection of the straight line with the y-axis. Okay, by the definition, what's the x-intercept? Intersection of the line and the x-axis. What's the x-intercept? Hey, don't tell me 2. It's not a number, it's unworded number pair. 2, 0. Okay? Yeah, write it in a formal way. X-intercept is a point. The point is 2, 0. So once again, what about the y-intercept? Y-intercept is the intersection of the straight line and the y-axis. Straight line and y-axis. Huh? Does not exist. They do not cross. They are parallel. Do you see they are parallel? Do you see the straight line x equals 2 and y-axis? They are parallel. 2 parallel straight lines, they never cross, right? So the y-intercept in this case does not exist. NDNE does not exist. Am I clear? Let's see number 5. Number 5, the equation, the given equation is y equals 95. Y equals 95. Okay, look at this equation. In this equation, we only see one variable, which is y. Is this equation still a linear equation in 2 variables? We talked about this yesterday. Yes, it is. Yeah. The reason x is not there because the coefficient of x is 0, right? Yeah, we talked about this yesterday. What kind of straight line this equation represents? Y equals 95. What kind of straight line? Vertical or horizontal? Vertical or horizontal? Y equals 95. Go down 1, 2, 3, 4, 5, 5 units. Straight line is a horizontal line, okay? Y equals 95 is a horizontal straight line. I want you to help me to find an x-intercept and a y-intercept for this horizontal straight line. X-intercept is the point where the straight line intersect x-axis. Do they intersect? No. You see they are parallel, right?
So the x-intercept does not exist. Do you see that? What about y-axis? Or what about y-intercept? Y-intercept is the intersection of the straight line and the y-axis. What's the y-intercept? This point, right? 0, -5. All right? So this example, we see the x-intercept and the y-intercept for slant straight line. For slant straight line like this one, right? Going down, slant or oblique, slant straight line. And this one is also slant straight line. And we also see the intercept, x-intercept, the y-intercept for a straight line. If the straight line passes through the origin. And we also see the x-intercept and the y-intercept for a vertical straight line. We also see the x-intercept, the y-intercept for a horizontal straight line. So this example includes all the cases. Any question about that? Any question about that? No? Okay. Let me see this section. I think we can move to the next section now. That is 3.1. Actually, we did 3.2 as well. Are you guys doing MyLab Math? So in MyLab Math, you should have chapter 1, chapter 2 both finished. For chapter 3, we did 3.1, 3.2 so far. Okay, 3.3. Talk about the slope of a straight line. Slope is a very important property of a straight line. It's like my hair color, my eye color, my height, how tall I am, how much weight. Those are properties of a person, right? Slope is a property of the straight line, of a straight line. Slope of a straight line describes the steepness of a straight line. And sometimes we see some straight line pretty flat, right? And some straight line very, how do you say that? Steep. Slope describes the steepness of a given straight line. Let's look at this diagram. Let's say you are here. You're going to drive from A to B, right? You're going to a slope. Yeah, you go from A to B. And slope is defined as the rise over run. Okay, the slope is defined as the rise over run. Rise is the vertical change. So when you go from A to B vertically, this is your change, right? Rise is your change. When you go from A to B horizontally, run is your change. So rise is the vertical change, run is the horizontal change. And firstly, I want you to please write down this formula. Slope is rise over run. Slope is rise over run. Rise is the vertical change. Run is the horizontal change. And next up, let's see this equation. This formula. Say L is a straight line. A and B are two different points on L. And we have two different points on a given straight line. One point is x sub 1 comma y sub 1. So the two coordinates for A are given. The two coordinates for B are also given, x2 comma y2. That's point B. Yeah. So suppose we know two different points on a straight line. We are able to compute the value of the slope of the line. And this is a pretty important formula Yeah, give me 1 second. I'm gonna write the formula on the board.
So let's say we have a straight line L, okay? A, x1, comma y1, B, x2, comma y2 are two different points on the line. Then the slope, we use m to be the slope. Then the slope of the line L, which is m, equals y2 minus y1 all over x2 minus x1. So this formula is gonna stay on the board. The formula gives us a way to compute the value for the slope of a line if we know two different points on the line. Yeah, let's look at this formula. Numerator, y sub 2 minus y sub 1. That actually is a change in y. Change in y. If we have a x1, y1 here, b x2, y2 here. So y sub 2 minus y sub 1 is changing y. X sub 2 minus x sub 1 is changing x. So it basically the same with rise over run. Numerator is the vertical change, denominator is the horizontal change. Do you have the formula copied down your note? I think the most important thing is how do we apply the formula? The most important thing is how do we apply the formula? Let's look at examples. To apply this formula to compute slope of a straight line, I have a three-step procedure. I'm going to show you how do we apply the 3 steps. Look at this example. Find the slope of the line passes through the given points. Okay. We are given 2 different points on a line. Yeah. One point is -1, 3. The other is 0, 1. We are looking for slope of the line, right? My 3 steps, I'm going to tell you the 3 steps to find the slope of the line. Step 2 is I'm going to label. I can actually do this here. Label the 2 given points. Yeah, I can label the first point as x sub 1, y sub 1. The second point is x sub 2, y sub 2. And then I will spend just a little bit of time to copy down. x1 is -1, y sub 1 is 3, x sub 2 is 0, y sub 2 is 1. Okay, that's the first thing I do. I label the 2 points as x sub 1, y sub 1, x sub 2, y sub 2. Which point is x sub 1, y sub 1? It doesn't matter. Yeah, what I'm trying to say is, if we label this point as x sub 1, y sub 1, this as x sub 2, y sub 2, it is okay. Okay? Yeah, I'm just following the order. The first point I label x1, y1. Second point x2, y2. That's the first step. Second step, you copy the formula. The formula I just wrote on the board. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Step 3 is you're going to plug in the 4 values for the 4 variables in the formula. When you plug in, please do what I'm doing right now. Use the parentheses to hold the place for those variables first. Okay? Yeah, numerator, parentheses minus parentheses, all over denominator, parentheses minus parentheses. Okay, the first parenthesis in the numerator, that is y sub 2, right? Yeah, you have those values right here in the purple. Tell me what is y sub 2?
Huh? Y sub 2, what is Y sub 2? Y sub 2 is 0? In the purple? Yeah, y sub 2 is 1, okay? What is y sub 1? What is y sub 1? 3, yeah, okay, put a 3 here. What is x sub 2? 0. What is x sub 1? Negative 1, okay. You know, every time I require my students, please apply the 3 steps. Don't omit, don't miss any step. And they do not listen to me, and then you know what happened? They do not have the correct answer. Seriously, you apply all the 3 steps, you can have the correct value for the slope. Let's continue here. Numerator, what's 1 minus 3? 1 minus 3. Okay, negative 2. Denominator, what's 0 minus negative 1? Minus negative 1. We talked about this in chapter 1, right? Minusing a negative number is the same with plus the positive number, right? Minus negative 1 is plus positive 1, correct? So the slope here is a negative 2. Slope here is a negative 2. Do you see that? Let's do a little bit extra for this problem. Yeah, for this problem, actually, we already done. We got the value for the slope. To analyze the result, we want to graph this line in the rectangular coordinate system. We can graph the line because we know the 2 points already, right? We have 2 different points already. Tell me, please, where is negative 1, comma 3? Which quadrant? Negative 1, comma 3. Which quadrant? Negative 1, comma 3. X is a negative, so to the left. Y is a positive, so above. So which quadrant? Quadrant 2. Quadrant 2. So we have 1 unit to the left, 3 units above, right? This is negative 1, comma 3. And where is the 0, comma 1? 0, comma 1. 0, comma 1. Where is it? Am I right? 0, comma 1 is on the y-axis, 1 unit above the origin, right? Okay, so let me connect the 2 points. And that straight line corresponds to the straight line which passes the 2 given points. Okay, so look at here. The slope we got is negative, right? The slope we got is negative, right? And look at the straight line. Remember, we talked about this when you read a book, when you read your phone, you go from the left to the right, right? Same thing. When you look at a graph in the rectangular coordinate system, you look at it from the left to the right. So when you look at a graph, when you look at a straight line from the left to the right, is the line going down or going up? Going down, right? Of course, if you look at it from the right to the left, then it's going up. But you look at the straight line from left to the right, then the straight line going down, right? Okay. So this is not a coincidence. This is the first conclusion that we need to remember. If the slope of a line is negative, then the line going down. Vice versa. If the straight line goes down, then the slope is negative. Can you try to remember that? If the slope is negative, then the line goes down. Vice versa. If the line goes down, then the slope is negative. Yeah, can you have that result in your note? If the slope is negative, then the line goes down. Vice versa. If the straight line goes down, then the slope is negative. Okay? That's the first conclusion. We have 3 minutes. I want you to copy the second problem. The first point, negative 2, comma negative 4. Second point is 0, comma 2. And you need to find the slope of the line passing through the 2 given points. The first point, negative 2, comma negative 4. The first point, -2, comma, -4. The second point is 0, 2, 0, 2. Yeah, I'll leave this problem for you to practice. And then you guys tell me the slope tomorrow, okay? Thank you guys for coming.